So welcome you all once again. So now we are having Earl Grey session by Gaurav and Sukumar.
Hello. A very good afternoon, people. Thanks for coming for the VodQa 2019 second edition. Uh, I hope everyone is energized after the break. Is that so? I see a lot of sleepy faces. All right. So we have a medicine for you. It's called EarlGrey. All right. I'm Sukumar. I've been with ThoughtWorks for the past 1 year, and I've got about 7 years of experience in iOS. That's pretty much about me.
Yeah, good afternoon. I'm Gaurav. I'm working for ThoughtWorks from last 2 years. I am a developer, mainly worked on iOS platform. Okay, let's start. So here's my question for you, Sukumar. What is EarlGrey?
Well, EarlGrey, let's ask that to the crowd. Well, can someone tell me what is EarlGrey? Type of tea? Yes, good answer. Anything else? Come on, people. What is it? Tea, coffee, or is it mutton chukka? All right, move on. So, we are giving you a clue. You see Gmail, YouTube, Docs. Does it ring a bell? Yes, it is open source by Google. What else? All right. So EarlGrey is an UI automation test framework that has been open source by Google, and all the applications that has been published by Google on the App Store has gone through EarlGrey testing. So yeah, that's what EarlGrey is. So Gaurav, can you tell me why we have to use EarlGrey?
Yeah.
I'll come back to that. Yeah.
So why EarlGrey? Right. If we move on the back slide, here we have test pyramid. So unit tests, yes, developers write lots of unit tests, and then integration tests, and then we have UI level on that. So mostly the integration test, it's about testing a screen or navigation between two modules or test screens. It helps developers to give faster feedback, and we don't need to wait till end-to-end test passes. Because integration test is, they are less costly than UI test.
Gaurav, let me stop you there. So I have a question for everyone here. Where do you think Earl Grey would fit in the test pyramid? Right? Yeah, I did call it out as an UI test framework. It is an UI automation test framework, but it is not advisable to do end-to-end testing using Earl Grey. For one, it is very expensive. You have to write two end-to-end testing for iOS and Android, or if any other mobile platform is there. So the reason we chose Earl Grey is to make it fit within the second section of the pyramid, the integration test. So we want this test to be less expensive. We want it to fail earlier and provide feedbacks. So if you see, uh, since it is less expensive, we can have it in our CI pipeline or even have it pre-commit hook, which would help us not to break the build. So if the test does not pass, we don't allow the commit. So the reason for having Earl Grey and Espresso separately is for faster feedbacks. Yeah.
Yes. Uh, when it comes to end-to-end test, we always suggest to use APM or Calabash, and we have seen majorly the projects have been following this. When it comes to integration test, yes, we have RobotM and Espresso for Android, and Kif and Algray for iOS. So
Yeah.
we can go with Algray.
Gaurav, I see KIF there, and I, for one, know that KIF is much more performant than Earl Grey by any standards. Then why did we choose EarlGrey?
Yes, you have valid point. Keep is a bit faster than EarlGrey, but there are good reasons why EarlGrey. First thing, it is backed by Google. We have active community. It has been open source. We can also contribute to it. So the community is also pretty active. It is comparatively faster than APM and Calabash. So a few test UI scenarios we can cover in this level. The other reasons are it's automatically synchronized. So Algray waits our views to render, and then it performs its assertions. So how Keef works? Keef generally go to lower level elements. It accesses lower level elements. It accesses lower level UPI, and it performs actions. So before my UI visible or before my UI comes up, Keef might have perform action and then perform assertion. But this is not how our end user would interact with our app, right? They will launch the app, they'll launch our app, they'll swipe, scroll, see the views, tap on views, and then they'll see the content. This is how exactly EarlGrey works. EarlGrey makes sure that before assertion, our views are visible. EarlGrey gives the feeling of how end user would work with your app. So, is it convincing?
Yeah, it is convincing. All right. People, do you have any questions until now? KIF is also open source.
Yes.
Yeah. All right. Any questions until now? All right. So, yeah, how to get started with EarlGrey? First of all, we would want to apologize a bit because we're going to repeat a few things from the espresso. Yeah. So it is similar, much similar to espresso. First, you will have to use a matcher to find the exact view, and then you have to perform an action on top of that. You find the view, perform an action, and then you assert what is finally required for you. So this is the crux. Again, you'll be repeating this.
So let me go to the previous slide just to explain a bit. So as Sukumar explained, we have 3 steps here. Find a view. We can relate with the associated example here. So this is how we can find the view with matcher. Then perform action. So we have actions, and then for assert, we have assertions. So here are the list of matches. We just took it from a cheat sheet. So we have matches for gray accessibility ID. Using accessibility ID, find the element. Using accessibility hint, label, trail, value. We have some UI properties here. For example, button title. I have simply say login button title. I don't even need accessibility ID for that. Then we have first responder, uh, then sufficiently visible, not visible text, text field values. Those all comes under UI properties. We have hierarchies, the classes, kind of classes. I can find all elements which are kind of class A or kind of class B, and then I can go through that. We have a few other matches, and everything is listed here. Yes. Then next comes action. So how user will interact with your app? Uh, Tap, swipe, scroll. So we have various actions here, various gestures here. Uh, uh, let's say we have login screen where user puts password and username. So we have those actions here, saying replace text, replace uh, clear text, tap the button, double tap, swipe, and then last part comes assertions. So simply, the most famous assertion was, is it visible or not? My component is visible or not? Then we can assert on test, text, and then various other objects. Okay, over to you.
All right. So yeah, so we'll dive in a bit and see how we can set up EarlGrey pretty quickly. So has anyone used Xcode or CocoaPods earlier? No. So if uh, you see a pod file here, right? So this is a gem. CocoaPod is a gem, and all you have to do is add your dependency inside a target, and it's gonna maintain it for you. So it will inject all the dependency that is required for you, and it will automatically integrate it. So if you see, there are two targets here. One is the actual target or the application, and the other is the test target. If you see, EarlGrey happens to not work in the UI test target, but it is under the unit testing target, right? So here on the left top, you see EarlGrey VodQa. This is one target. All you have to do is add this dependency here, then run a command called pod install. Well, your dependency is injected. Yeah. So if you see, you will have your okay. So if you see, we have the EarlGrey framework here, right? And this is part of the EarlGrey VodQa test target. So we have two targets here. One is the actual application, and the other is the unit test. Uh, all right. So if you see, initially you will only have one scheme for starters. So when you open a project and you add CocoaPods to it, you will only see one target. You'll have to create a new scheme here, make sure the correct target is selected. So here, if you see, you select this and you'll get another option to say whether it is an unit test or an XUI test scheme. So yes, so you add a unit test scheme, and then that's pretty much about integrating VodQa. So before we dive into all the test cases, we will see, we'll do a small app walkthrough. This is a pretty small app for the demo. So we have a login screen. I'm gonna enter username and password. I'm gonna log in. We have a list of items. So let's see how we are covering tests for all of this. Before we write the test cases, let's see how we can assign identifiers for each elements. So we see for the first screen, we have a text field. This happens to be the username. So there are different properties here. You have label, hint, identifier. You can even use class names or the type of UI element it is to match this and fetch this element. Right now, we are going to use the identifier here. So for this field, since it is the username, we have given the identifier name as username. And then the password is identifier. And for login, it is login. So for people who think this is very hectic, there is a tool called Accessibility Inspector, which is provided by Xcode itself. All you have to do is run the simulator, make sure it is active, go here, select the device that is connected, select the device, make sure that the application is selected, target is on. Now if you go here on the left, you will see all the different values like identifiers and everything. You won't even need an external inspector for this. You can also see the hierarchy of where it is being placed in case you're using the hierarchy matcher. So yeah, so since we have the initial requirements or parameters or arguments that we have required for their test, let's see how we write a test. So this is within the unit test target. We'll come back to the setup later. So for testing the login screen, the first test says select element with the matcher. Here the matcher is gray underscore accessibility ID. So we are fetching the fetching an element with the accessibility ID as username. And the second part is the action. So we don't have, do we have an action here? No, we don't have an action. So we need not perform an action here. We are just going to check whether this item is visible or not. So we can directly jump to assertion. We are asserting whether the item is visible or not. So we have three elements here. We are asserting all the three elements, whether they are within the screen or not. So yeah. So the second is a test login failure. We'll do the success first and then come back to the failure. So it is the same. We are fetching the username and then we are performing an action here. Here the action is we are replacing the text with the username. Here the username is test. And then it is similar for password. For password, we are replacing it with password. And then for login, if you see, we are fetching it using the accessibility ID login, and then we are going to perform the action, which is a tap. Right. So how we are asserting whether this login has been successfully done or not is by making sure that the next screen appears. So when the next screen appears, we check whether the list view has been presented or not. So this is a success scenario. Whereas for the failure scenario, we assert whether we got the error message. So the error message is something like this. Yeah. So it just says, please enter a valid username and password. So let's see how the list of tests happen. So there is a small bug which would probably be fixed in the next versions of EarlGrey. So since Swift 5 came in recently, they've changed the syntax a bit. So only the first line needs a fix. So it logged in. Now it's trying to go to the last element, and again, if it is scrolling back to the first element. So now can someone tell me the difference between a normal test framework and this EarlGrey? Did someone feel a difference when the simulator was running through each screen? Does it happen the same way in APM also? So I'm going to run the test again and try to explain. Sorry about that. If you see, when the app is scrolling, it is trying to reproduce the user's actual scroll and not trying to go inside and access a private level API. So this is what Gaurav meant by being synchronous. So you are actually you are simulating the user's gesture, what the real user would do, and then we are navigating through each screen. This way, your app is going to be synchronous. There is no way you can break it, right? But EarlGrey also provides features where you want to control the flow by yourself. So you get the best of both worlds. So we'll see how we perform the scrolling, which we saw in the second screen. So here we have select element with gray accessibility ID, which is as usual, but we are using something called as using search. And we've provided this scroll direction. First we say it is scrolling down, and then we provide a value of 250. What this means is it will try to scroll by 250 pixels each time and search for that particular item there. So it will keep going until it reaches the end. If it has found it in between, it will stop right away and assert the test case. So yeah, so once it has found the last item, it will perform a tap, and then, yeah, it performs a tap, and then we scroll back up. And then we scroll back up and we assert the first item. That's it. So that's about the demo. Does anyone have any questions? Yes.
What is the difference between Espresso and EarlGrey? Are they both used for the same?
I mean, it's Espresso is for Android and EarlGrey is for iOS. That's all. Okay. So both of them are native UI automation frameworks. So that's why Google has named them as Espresso and EarlGrey.
Okay.
Yeah. So there is a plugin for mobile web. So few applications do have child browsers, right, inside the application itself. There is a plugin which allows you to test mobile web also, but it is not as effective as the other web frameworks. Okay, yeah, so that was a point which we were supposed to cover. So whenever a test fails or an exception happens, EarlGrey has an inbuilt method where it will capture a screenshot of that and it will store. So if you say iOS applications are sandboxed, so you have a certain place where these screenshots will go and get stored. So I'll show you that path. Let me file a test case first. So I'm going to change this assert value and I'll run the test case. Yeah, it has failed. Yeah. So it is saying this is where the test case has actually failed. And it is also showing which element was tapped before it failed. So this would be a good place where all the logs are stored in the form of screenshot. Or you can have your own logging, like there are frameworks like Timber and the others, which would cast your exceptions and they would log it separately, which can be used to build a test report page. Yes. So here it comes as inbuilt.
Okay.
But the only problem is there is no proper a feature where a test report is displayed. Like Spoon has a good UI where it would display all the test cases where it is passed or not.
Okay.
Here, since Google is always slow with iOS, they have not introduced it.
Okay. Okay, then one more thing, with respect to Orchestra, where you can use the same Android Orchestra here?
So Orchestrator, by Orchestrator, I heard Kanti say that you can have multiple devices running at the same time, right?
Okay.
Here it is not possible. So you can run a build only at one time. So there are functions like tear down and all these things where you can reset the application and start from the beginning.
Okay.
Yeah.
Okay.
So there is a method here. So if you see here, we have a setup. The setup is called first, then the first test case runs. Then teardown is called where you can reset the application if required and then run the next test case.
Okay, remove the cache, everything.
Yes, everything you have to reset it manually.
Okay.
It is not provided out of the box by EarlGrey.
Okay.
So if you see, it comes out of XC test case.
Okay.
XC test case has all these features.
Okay. But anyway, the performance will be slow because thing is we are doing like a manual user, so the performance will be a little bit slow.
Yes,
with respect
yes.
to elements.
But if you go for KIF or other frameworks, even before the UI is rendered, your action would be triggered.
Okay.
So there is no way you can assert whether the element was actually visible or not.
Okay.
Yeah. So you'll end up synchronizing it more.
Okay, but sometimes it may go wrong, correct? If the element is not.
Yeah, for KIF. You mean for KIF?
Yeah, KIF.
Yeah, KIF, yes.
Okay.
That's what you will end up synchronizing it more. Like you'll have to wait for the UI, have some delays, and then wait for the UI to synchronize it.
Okay, sure, thank you.
Cool. Any other questions? All right, before closing in, I just wanted to say where you can set the path for saving all the screenshots. So iOS is a sandbox application. You cannot save all the logs or assets outside this sandbox. So there is a particular folder which I just opened. Uh, so you'll have to set this path, even though we say here desktop. Uh, you can see that it has created in a desktop folder inside the sandbox, and that is where you can store it. So this is the only disadvantage. You'll have to go inside the sandbox and check for all the logs or screenshots.
And straightforward. So we have some known issues in EarlGrey. For example, if suddenly some system alert comes up, so EarlGrey is not able to dismiss it. It's a little flaky, but yes, all UI frameworks will come with a bit flakiness. We have a solution for that. We can disable the animations, but then there will be no difference between like EarlGrey and Keef. And yes, it is still part of a unit test scheme. So what do you say? We have system alert which can't be dismissed, and it's still part of unit test. Should we still go with EarlGrey?
Yes, Gaurav, I do agree that system alerts do break the flow. But for that, we have EarlGrey 2.0. So to prove that Google is contributing to this very actively, EarlGrey has come up with, Google has come up with EarlGrey 2.0. So all the issues that we have faced in EarlGrey version 1 has been addressed in EarlGrey 2.0. For starters, it comes it comes under the UI test framework. So it is possible to do end-to-end testing here. Yes, I just want to see. Yeah, and they also claim that it is faster than EarlGrey 1.0, less flakier. So yeah, it's still in the alpha stages. Let's hope that it is better than EarlGrey 1. That's it. We're done. Any questions, people? Before we wrap up. Yeah, you can access. So if you see the system alert comes outside, it's outside the control of the application, right? Uh, spin, you're talking about spinners, right? Spinners and all are accessible. So whatever is created within the application is accessible. Only thing is that let's say you're opening in the application for the first time, then it will ask you to give access for location and all these things. At that time, it is not possible to dismiss it. So there are other tools, but they are not very successful tools, which will allow you to block these alerts from happening in the simulator. Cool. Any other questions? Yes, we have it in production. It you should, I mean.
And one more thing is, it's possible to integrate it with unit test. So whenever in
Yes.
Xcode you are doing command, which is a command to run the test, along with your unit test, EarlGrey test can be run.
Yeah.
Yes.
So right now in a production project, how it happens is end-to-end testing is handled by the QA team, and so all the EarlGrey tests for now the devs write it, and what it helps us is we don't have to wait for a longer feedback loop. Like a regression happens for a week, we'll have to wait for the regression to complete and then fix it. Whereas here EarlGrey, it fails then and there, so we fix it then and there. Right. That's it. Right. Thank you, people. Thank you for your time. So here are the references from where we started this. Yeah, thank you. And we would end up by saying, telling people to pray for Nesamani. Thank you.
Thank you, Gaurav and Sukumar. So meanwhile, we can fill the feedback for this session. So our next session will be like So our next session will be testing without any real testing by Deepak. So one of our thought worker.
Hello. Okay. Okay. So my talk is about doing testing without any real testing. Okay. So how many of you guys think this is a clickbait? Do you think do we have enough substance to substantiate this topic, or do you think it's a clickbait? Like you can feel free. Like you just raise your hands. Like if you feel it's a clickbait. Nobody feels so. Is it okay? So my next question would be, how many of you think this got something to do with artificial intelligence, doing testing without any real testing? Nobody feels. Okay. So what do you guys think? Like, okay, so you don't think this is a clickbait? You don't think this got anything to do with AI? So what this could be? Uh, so, the thing that I'm going to talk today is it's called search-based software engineering. So they are applying this technique in software testing. Okay. Uh, so, okay. Okay, so actually, I'm not a practitioner of this technique, like software search-based optimization testing. I'm not an expert or a practitioner in this. Thing is, actually had came through this thing like. So there is a tool called Sapiens. Okay, and this is a tool that is widely used in Facebook now, and this is based on a research paper on search-based software engineering. And so I have two objectives for this talk. So one is I'd really love to introduce this technique to you guys. And the second thing is actually whenever I would want to keep myself updated, what do I do is actually I read blogs of companies that I feel they are doing cutting edge things like Facebook or Netflix. So only then I came across this Sapiens. What I really understood is actually there is a whole lot of other things happening in another space beyond what is happening in these top companies. That is the research on software testing. Actually, there is an year-on-year symposium that is conducted by IEEE and other research academies. Actually, they are doing a lot of work, and I guess nobody pays attention to any such things happening. Actually, there are a lot of lessons for us to pick up from those research things, and for us use it in real time. So Sapiens is one of our best example. Like it was presented as a paper, and actually Facebook hired the whole team of people who actually presented the paper, and they are employees of Facebook now. And interesting fact is, when they presented this paper, they used this tool to test 1,000 apps from the Play Store, random apps for which they don't have any source code or they don't have any domain knowledge about that app. They just randomly take some 1,000 apps, they test those apps, and they find around 780 crashes. And they reported to our developers, and more than 75% of these crashes are recognized by the devs, and those got fixed. So this is the background of Sapiens, and now it is into Facebook, and actually it's not open source till now, it's a closed source. And last year, there was a presentation by this team, and by May 2018, it had actually found 382 production crashes in Facebook Android application. And those got fixed and released. Okay, so actually there is a whole lot of other stuffs happening, and a lot of us are not even aware that something of this sort is happening, and we would be able to use these techniques in our day-to-day work. Okay, that's it. So I'll try to introduce you to what is search-based optimization and how does it used in software testing. Like I'll start with a small example. Okay, another disclaimer is the reason that I'm doing this talk is actually I myself wanted to read about this technique, and I've never been able to allocate time. Okay, so if I gave my name for this talk, and I'll be left with no other option other than read it and do a session. So my knowledge on this is spanning for just 3 days. Okay, so you just post me questions. I may not be able to answer all the questions, but I guess I'll tell you whatever I know. Okay. Okay, let's take this. You guys are able to see this function, right? So it's just a simple add function. It takes 2 integers and it returns an integer. It's a sum of the integers that we had passed it. Okay, very simple thing. So for us to test it, okay, I want an automated way to test it, okay, without any manual intervention. I'll just have to write a program that will test this function. Okay. So what are all the possible things that I could think of is, so I got two integers. Two ints are the inputs. So what I can do is all possible values of int. I can do that for this function from negative range to positive range. I can try passing in all combinations of input and I can validate my output. That's one way of testing for me. So what would be the problem if I do this? Like if I go about testing this with all possible inputs, like what would be the problem? It's not possible. Why? For all the integers, yeah, actually it's going to take a lot of time. And actually this is a very simple method. Like if I'm giving you a complex method with complex input like string, for which I can pass different set of values, like it's going to get really complicated. So really testing with all possible combinations is not possible. Second method would be random inputs. So I know these two are integers. I can just pass some random inputs and see how does this behave. But what is the problem there again is, this may not be representative of all cases that I would really want to test. It may not cover all the cases that I really want to test. So that's when a human tester comes in. So what does a human tester do? He will come up with test cases that will cover all possible cases. That will cover all the code flows, right? So not just the code flows, we'll look for some common patterns, like what will happen for negative, positive, and stuff like that. Yeah, exactly. So, yeah. So these are all the three things. So what is done with the search-based optimization is, they had taken this sample set, okay, and they had tried to apply this intelligence over that and try to come up with set of inputs that make sense. Okay, so the intelligence that we have is, I want a code coverage, like my coverage should be higher, and I should choose enough sample set that all my cases are covered, right? So we call this as fitness function. Okay, and I call this as sample set. So I got a sample set, I got a fitness function. I'm going to apply this fitness function in the sample set and decide a set of inputs that I feel that would be practical and that would cover enough test cases for me so that I'll be confident in releasing this product. Okay, so how do I apply? Like again, as I said, this combination is going to have billions of combinations. Just for two inputs, from positive to negative, I have to test it with combinations of all the things. So this is going to take a lot of effort for me. So that's when this technique called search-based optimization comes in. Okay, so actually there are a handful of algorithms to do this. Okay, so first algorithm is called hill climb. And second, genetic algorithm. And third one, it's simulated annealing. Okay. Okay, I'll just try to introduce you through all these techniques. Uh, so one of the widely used is this genetic algorithm. Okay, this is based on the evolutionary theory, like Darwin's evolutionary theory. Based on that theory, this algorithm is developed. And actually, these algorithms are also used in machine learning techniques to find the optimal outputs there. So let me explain. Okay. So let's assume this is my inputs. Okay. So actually we have two inputs. I'm just combining them into a single input. Okay. Let's say I have these are all possible inputs that I can have, and this is my fitness function, like output of the fitness, like does it have enough coverage? Okay. So how does a hill climb algorithm works is, in this full sample set, it just randomly picks a point, okay? And it computes the fitness function. Let's say it falls down here. What it does is, next is, it takes the input of this point and calculates the fitness function. So this place might be a bit down, and this place might be a bit higher. Okay? Then the hill is climbing. So it moves its input to this point. Then what it does is, again, from this point, it tests 2 points. So if this point is better, it will move in here. If this point is better, it will move in. Like that, it keeps moving until it follows a downhill. Okay, like, are you guys with me? Like, are you able to follow me? Fine. So this is an input that I would really want to use. Okay. But the problem is, let's say there is another hill like this. Okay. But since I had reached this point and I had started seeing the downfall, I'll stop here. So this, they call it as local optima. Okay, I'm using a lot of jargons, like don't get carried away. So what the problem with hill climb is, it may not find the best input. So it might get stuck here in some random local optimas. Okay. So that's when the second technique, or like I'll explain this simulate analysis. So in simulate analysis, the different thing is, it will not stop when there is a downfall. Okay. So it keeps, even if there is a downfall, it keeps continuing. Like it keeps continuing in both positive and negative. And it will keep trying to improve, but this is very costly technique. So one thing that I would really want you to understand is, actually we don't have a graph at all. Like if I had computed fitness function for all these things, it is like testing all possible combinations. That is not at all possible. That's why we choose these algorithms. Like we choose a random point and we just try to go up and come, and we choose this as a point. Okay, so with genetic, what happens is, let's say my graph looks something like this. Okay? And by genetic, what do we mean is, we choose lot of different points. We choose lot of different points and see which like, let's say if these 2 points are giving me a good result, then what I'll do is I'll try to mutate them. I'll try to combine, so this is called a crossover. I'll try to cross over these two and I'll find another point. So that point might lie here. And for these 2 points, that could be, the crossover might fall here. Okay? Then I might try to find crossover for these two, and that might fall somewhere here. And again, we are not sure that this would give us the best solution, but it will give us a good solution. It will give us input that would, solve our purpose. It may not be the best solution, but a good solution. Okay? So this is high level of what search-based optimization techniques. And okay. So let me show you an example. So you guys are able to follow this, right? Okay, so now I am using a tool called EvoSuite. Actually, I just found it today morning, okay? One of the interesting thing is, I'll quickly show you this graph, okay? So this is the paper where in which they had presented Sapiens. And in this tool, they had listed a lot of tools. Interesting part is these techniques. These techniques, so the thing that I'm talking about now is search-based. So this is where Sapiens is, okay? So see, there are hell a lot of other techniques like random-based, model-based, program analysis. I don't even know what these things are. And there are hell a lot of tools. Most of them are open source tools that are there for us to evaluate and try. And they have implemented, these techniques, and they are available, and most of us are actually not using these things. Okay, so so this is a function that I have, and I'm now going to generate test cases for this function. So I'm going to say, okay, so it's generating. Get it completed. So you could see this had generated two test cases for me, sorry, three. So one is result that gives out 0. Second test that tests for negative value. And the third test, it tests for positive value. Okay. So I was quite surprised today morning to see the test cases that I generated. So I really wanted to see if it, adopts for the change. So I introduced another thing. I changed it and see how my test cases changes. So if I say change this into a calculator, that if it returns 143 and I would want to return huge number, okay, I may call this as low calculator or whatever. Okay, so now I changed this method. So let's see how my test cases getting changed. Like I'm going to run the same thing again. Okay, that completed. And let's see. So my first test case, it checks for a positive integer. Second, it checks for a 0 output. Third, you see, it had added a new test case that pass in 1, 4, 3, and 0 and see if the expected output is whatever the big number that had tried giving. Cool. So the fourth one just remains the same, like it tests for a negative number. So actually this was quite surprising for me. Like I was able to generate test cases, that I don't have to write. Actually, this tool is pretty good. Like this does not just takes input of integers, strings, and things like that. It takes file input or a network connection or a DB connection. It's able to mock these connections and it's able to generate tests based on all these stuffs. Okay. Okay. So let's come back to okay. So let's come back to Sapiens. So let's see how these techniques are applied in Sapiens for us to really test the Android app and find the issues in the Android app. So basically now what they are using it for is to find the crashes in the app. So that's the main thing that they are trying to use this tool for. Okay. So okay, now we talked about passing integers. When it comes to Android testing, what Sapiens does, it actually it tests the entire application like as if a human is going to test it. Okay, like how do we come up with this thing? But if you see all possible inputs, it could be the way that I'm going to enter my username, password, and after logging in, my flow could differ, right? Like I could go see a list of friends, I could go post, I can do hell a lot of things. Like the real combinations of things that is going to come up is enormous, and we will not be able to come up with all sort of things. So what they do intelligently here is actually they are doing a black box testing. Actually, they are entering things and going through the flow. But the way they are choosing which flow that they have to do. Let's say, for example, so here, the different flows could be, I could just be randomly clicking here, or clicking here. Or a meaningful flow would be, I'll be entering a username, password, and clicking this button. Okay, so I could list random clicks and just click without entering value. Or a valid flow. So again, I'm telling, like, this is actually not a functional testing tool. So they are primarily using this for the crash detection. So they would want to try all the flows in the application and see where the application actually crashes. So a valid flow. So there, this flows are called as genes. Actually, how do they do is, let's say a click, and a text, or text, and a click, or a text, a click, a text. Let's say these are all different operations, okay? So, and had combined these operations to form a gene, okay? And they identify certain genes as motif genes, okay? So I really don't know how to explain it, but this is a biological term. I'll just read through it. In genetics, a sequence of motif is a nucleoid or amino acid sequence pattern that is widespread and has or is conjectured to have a biological significance. To the terms that I understand, if I explain it, a meaningful flow. Out of all the flows that I have, I'll pick and choose a meaningful flow that I have. Okay? So first thing that Sapiens does it actually lists down all the sample spaces and it comes up with this motif genes. Like it finds the flows that are actually meaningful that we'll be able to use. So that's the first things with motif gene. The second thing is the genetic algorithm. So they find all these motif genes, they list them down, and they apply a genetic algorithm on that to find the list of inputs that they really want. So there, what are all the fitness functions they use is, the first thing is coverage. The second thing is the length of sequence. Okay, so and third is probability of crash. So these three are the fitness functions they use, and they come up with sample set using the motif genes, and they apply these two to come up with the ideal flows that they would really want to test this app with. Okay, and yes, so and actually they go beyond the team in their talk. What they had claimed is like beyond just capturing the crashes. So what they did certain things very intelligently. Say for example, it runs as part of the SCI. Okay, so if it finds a crash, what they do is it will try to find a commit before a last passing build and the first failing build. Okay, and they check what is the diff and who committed the diff. And based on who committed the diff, actually it notifies the dev that your your commit had actually crashed the build. Okay, and between these two builds, if there are 4 or 5 commits, okay, then I'll not be able to find which they've actually caused this crash. So what they do there is they look at the stack trace and find the line and see which developer had actually committed this particular line that had caused the crash, and they notified that dev. Okay, and 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 they go about fixing these defects also. Actually, they call it as SAP fix. Okay, and again, these techniques are I find them interesting that I thought I'll share. So first thing is actually they revert the build. So based on actually they do analytics and find if this crash is going to affect beyond certain number of users, they directly go ahead and revert that the commit and release the app. What if there are more commits on top of this particular commit? They go about doing a partial revert of this thing. The third thing is actually they have an AI engine that suggests a fix for this particular defect. Actually, the AI engine that I'm talking about, actually they had open sourced this tool. So if you go search for Sapiens, and you'll be able to find it in the Facebook blogs. This tool, it's an AI tool that's actually they are using in their production that they had recently open sourced that fixes the defects. Like based on all the fixes that was done previously, they had used machine learning and they are able to fix defects here. And the fourth way that they are doing fixes, So they break down this particular piece of code into abstract syntax tree, like you guys are aware of AST. So that's a way of representing our code uh, into a certain graph sort of way, okay? And they again implement the search-based technique to fix the defect there. So actually, I'm not really, aware of how do they do it. So again, they are applying this search technique there again to fix this defect. Okay, I guess I'm done. Cool. This is all, guys. Like, you guys got any questions? You're good. Yeah.
You are showing some test cases, right?
Yeah.
Yeah, you have shown test cases. Can we see what is the method, how you are build that?
Yeah. So actually, I had used this. So this is IntelliJ, and I had used this thing called EVOS Suite. Okay, this is a plugin for IntelliJ, and actually you can find Okay, so there are some good talks. Actually, I had copied most of the contents from this talk. Like, so this is the JUnit plugin, like IntelliJ plugin that I had used to generate the test case. So this guy, okay, so you can just search for EvoSuite, like you'll land up in this thing. So actually, he would explain things that I had explained here very in a very good manner, and also you can just search for Sapiens. Okay, you can just search for Sapiens Facebook and see there are quite a number of videos. So these are all the guys that who had developed it. So there are good videos, and actually there are papers. So this is one of the papers. So you'll be able to find content here. The thing is, actually there are a lot of techniques out there that is happening that we are really unaware of. So that's the most striking thing that I would want you to leave with, actually, and for us to look out to keep ourselves updated on what's happening. Cool. Test cases, yeah. So, okay. So, actually, I too had the same question. Thing is, I don't see test data and test case as two different things. They combinedly create my test. So, if I change my test data, it changes my flow also. The
Because I could see that when you were explaining, right, you are explaining the graphs and what are the theory you were explaining. It's mostly on the test data part. But when we're generating the cases, it's meant for a test case.
Yeah. So yeah. So in this example, x and y are actually the test inputs. So I could define my test case as, for negative numbers, how does it behave? That's a test case. For a positive inputs, how does it behave? That's a test case. Or even in this case of Android application, actually it tries to find the flow of the application. So that becomes a different test case. So actually I don't have to write this test case, like I log in, I see my profile and photos, what does that happen? So it actually automatically finds all these flows and comes up with the thing. Actually, in some of the papers that I had found, okay, actually they had used in these techniques very, like some 10-15 years back, even then they had used this to test okay, so this is called temporal testing. Actually, I found it in another paper. Okay, so temporal testing, what does it mean is best case execution time and worst case execution time. So that's temporal testing. Okay, and I was just wondering, like, what the hell? Like, why do I even want to test this? And The use case is the airbag opening. So, is my airbag opening algorithm, does it get triggered very earlier, or is it happening at very later state? Okay, if it is happening in very later state, I might even finished my accident thing, and then the airbag might have opened. So that's the worst case. And the best case is even before I get into the accident, it opens. So, so they had actually applied this search-based technique to test uh, temporal testing. Cool. Good. Thanks, guys.
Yep. This is a time for filling the feedback. And first session for debug, you can fill the feedback. Along with that, we are ending up now. I think the overall content-wise and then VodQa level feedback, if we have anything, there is a separate section in the down. Um, any logistics issues or anything you feel the content-wise you want to give or share with the feedback, or you want to present anything, you can mention there. We'll pick it up and then reach out to you guys. Okay. Yep. We have snacks in the cafeteria. I think we'll go in and then we can have a tea and then chat. If you want to have any clarification with the talk who are given that. Otherwise, if you want to chat within us, I mean, how we'll work